Good evening, everyone, and welcome to our 7th annual Dark Sky Festival, where we are bringing the stars to you. The Sequoia Parks Conservancy has been hosting the Dark Sky Festival here in Sequoia and Kings Canyon National Parks since 2014. And since then, our purpose has always been the same, and that is to inspire awe and create a lasting connection to the night sky. And even though we're virtual this year and we're not together, we are still holding true to that purpose. My name is Katie Wightman. I'm the Field Institute Director for the Sequoia Parks Conservancy, the official nonprofit partner to Sequoia and Kings Canyon National Parks. And I am so excited for this virtual star party tonight. If you have ever attended one of our festivals here in the park, you'll know that our Saturday night star parties are the most popular event of the weekend. And even though we're not together this weekend, we're not there at a star party where we're looking through the telescopes, we still want to bring the stars and the star party to you virtually and give you the opportunity to learn a little bit about the night skies here in Sequoia and Kings Canyon National Parks. Tonight, we'll be taking you on a tour of the night sky through an amazing app called Stellarium. This is a wonderful app that you can access from your computer, or you can download it to your smartphone. And we're also going to be splicing in images of deep space objects and planets, so you get an idea of what these objects look like through a telescope and what you would see here in the parks if we were standing here together. Now, tonight we're also going to be traveling through the night sky using the constellations as a guide as we navigate and start creating a celestial map. And my hope is that you begin at home as you're watching this video to create your own celestial map, so that wherever you are, you can start exploring the night sky on your own with your map, and that you'll continue to build your celestial map long after this video ends. The simple definition of a map is that a map is a representation of a place. Our place tonight is the night skies of the Northern Hemisphere here in Sequoia and Kings Canyon National Parks. But before we start, I want to encourage you all to think about where your place is. Where are you right now? Because that's where we're going to start building your map. And tonight, we're just going to start with some basics. But your map, the one that you're starting in your place, has infinite possibilities. And tonight, I challenge you with this question. How far and how deep will your map go? We begin creating our maps with 2 constellations that help us to find north no matter where we are in the Northern Hemisphere. And those are the constellations of Ursa Major and Ursa Minor. Now, Ursa Major is hidden behind a tree a little bit, so we're going to get rid of the landscape so that way we can see the 2 full constellations. Ursa Major and Ursa Minor are commonly known as the Big Bear and the Little Bear, or the Big Dipper and the Little Dipper. But many people and many different cultures see so many different things when they look at these constellations in the northern night sky. Some people call it the Big Dipper and the Little Dipper. Some call it the Plow. Some call it the Drinking Gourd. And others call it the Great Plow. As we begin our celestial maps with these constellations, I first encourage you to look up all the stories and all the songs that are really focused behind the Big Dipper and the Little Dipper, and find the one that resonates with you and make it a part of your map. In Stellarium, we see these constellations represented as the Big Bear and the Little Bear. But this is Stellarium's celestial map. It's not yours. And I encourage you to make your map your own. So find the story that, again, resonates with you. Ursa Major and Ursa Minor are not only some of the most recognizable constellations in our northern night sky, but they're also exceptionally useful for helping us to locate north on our map. So where we'll start is by looking at the 2 stars that we call the pointer stars of the Big Dipper of Ursa Major. So the constellation that we normally see are made up of these three stars here, 1, 2, and 3, which makes up the handle of the Big Dipper. And these 4 stars here that are 1, 2, 3, and 4 that make up the dipper of the Big Dipper, or the gourd of the drinking gourd, or the wagon of the Great Wagon. So these 4 stars, again, make up that other pivotal point. But these 2 stars in particular, 1 and 2, are the 2 pointer stars. Now these 2 stars, if we were to follow the orientation of these 2 stars and draw an invisible line towards Ursa Minor, we land on this star here called Polaris. Polaris is our North Star. Polaris, when you find Polaris, you are facing north. And so again, these stars here, 1 and 2, are the pointer stars that help us to find Polaris. So you follow the orientation up to Polaris. Now Polaris is at the end of the handle of the Little Dipper. So we go 1, 2, and 3. We have the handle of the Little Dipper. Then we go 1, 2, 3, and 4 to make up the dipper of the Little Dipper. So these are our 2 constellations. And again, we'd use them to help us to find north. Near the constellation of the Big Dipper is our first deep space object, and it's found just below the end of the handle. And our first deep space object is M51, or the Whirlpool Galaxy in the constellation, just below the constellation of Ursa Major. Now, first, we're going to start as we zoom in on M51. We are going to start with the Stellarium image of M51. Now, the objects that we're going to show you tonight, we're going to first start with Stellarium, and then we're going to splice in those photos of what you would see through a telescope. Now, the photos that we're going to be splicing in are photographs that we took through our 11-inch Celestron telescope. We wanted to try to keep the images as close as possible as to what you would see if you were here with us in the parks looking through a telescope. Now, with that being said, the images that you're about to see, the Stellarium image, or the ones that you see that were taken from the Hubble telescope, are a lot more detailed than the ones that we're going to show you. The ones that are going to show you are going to be a little bit smudgy, and they're going to be mostly monochromatic. Now, getting back to the Whirlpool Galaxy, the Whirlpool Galaxy is located 31 million light years from Earth. Now, we're going to show you what it would look like as if you were looking at it through a telescope. When you look at M51 through a telescope and here on Stellarium, you'll notice that there are 2 main parts to it. That's because there's actually 2 different deep space objects here that we're seeing. One is the Whirlpool Galaxy, which is M51, and the other one is NGC 5195. Now, NGC stands for the New General Catalog of Nebulae and Clusters of Stars. And when we see, so M51 is the bigger object here, and NGC 5195 is the one over here to the right. And actually, this object here is passing behind M51, or the Whirlpool Galaxy, and it's been doing so for the last hundreds of millions of years. The Whirlpool Galaxy was discovered by Charles Messier in 1773. Now, most of the objects that we're going to be looking at tonight are classified with an M number, and these are the deep space objects that Charles Messier discovered in his lifetime. When Messier was building his celestial map, he saw objects in the sky that he didn't know what they were. With the technology that Messier would have had in the time in 1773, he would have seen these objects as not the thing that we're seeing today, or even the object that we would have seen through the telescope today, but he would have seen the object as kind of smudges in the night sky. And what I love about Messier is that even though he had no idea what he was looking at, that didn't stop him from marking it on his celestial map. I like to think that Messier, when he marked these on his map, that he was actually kind of putting a question mark on his map. In total, Messier cataloged 110 astronomical objects, or like I like to say, astronomical questions on his celestial map. And I think the best maps have a lot of questions on them. As you continue to build your map tonight, I'm sure you'll have lots of questions on them. And as you continue to explore your map beyond tonight, beyond this video, and go deeper into your map, the more questions you'll have. And hopefully, along the way, you'll have more answers too. Now that we have located north on our maps here at Polaris, we're going to go ahead and travel to the western sky. Now, as we've learned to find north using Ursa Major and Ursa Minor, our other directional points are relatively easy to find. So when we're looking north here at Polaris, to find south, it's pretty easy. All we have to do is turn around, do a 180, and look right behind us. And there we have essentially south. Now, once you find south, you can go back to the north and look again at Polaris to help you find east and west. When you're facing the north and facing Polaris, all you have to do is remember this simple thing. The sun rises in the east and it sets in the west. So as you're looking towards Polaris, you just need to remember where the sun rises, and you will know once you figure out where the sun has risen, the day before, that morning, you'll know where relatively east is, and you remember back to sunset, where the sun set, that will get you essentially right around west. Now tonight, we're going to travel through to our western sky, and we're going to visit the constellation of Hercules. One of the 12 labors Hercules was assigned to atone for his sins was to bring back the golden apples of Hesperides. Now, in order to get these apples and complete this task, Hercules actually had to defeat the great dragon that was guarding the apples. And tonight, when we look into the night sky and we look at our constellation art, we can actually see Hercules stomping the head of Draco the dragon. And once Hercules was able to defeat Draco, he was able to grab those apples and complete that one of his labors, his 12 labors, and go on to atoning for his sins. But I will say that in order to get these apples, Hercules did have quite a bit of help from Atlas to do this. Now, within the constellation of Hercules, we have our next deep space object, and that's in the keystone right here of Hercules, or the kilt of Hercules, and that is the object M13, or Messier 13. M13, or the Great Globular Cluster, or the Hercules Globular Cluster, has over 100,000 stars and is one of the brightest star clusters visible in the northern hemisphere. M13 is located 25,000 light years from Earth and can be spotted actually with a good pair of binoculars on a dark night. But now that you've seen the Stellarium object, we're actually going to go ahead and show you what you would see if you were to look through a telescope. All right, so now that, again, as we're looking at the Stellarium object, we can see the Great Cluster. Now, a globular cluster is a collection of stars that orbits a galactic core, and they're very tightly bound by gravity, which is why they're really spherical in shape. Now, globular clusters are still somewhat of a mystery. They have some of the oldest stars in the galaxy, and there's actually quite a fair amount of them in our Milky Way galaxy, about 150 to 158. But scientists don't really know how or why they are created, and it's still really unknown. There are still a lot of mysteries in our galaxies, and globular clusters are just one example of that. Scientists are still trying to solve the mysteries of our galaxy and our universe on their celestial maps. And the deeper we go into space, and the deeper we go into space, and the deeper we go into our maps, the more complex our maps become. As you mark the Great Globular Cluster on your map, know that you're not only marking this really cool globular cluster, but you're also marking a mystery. And I think it's fair to say that there'll not only be a fair amount of questions on our celestial maps, but there's going to be quite a few mysteries too. Next on our map, we are going to travel to our southern sky, and we are going to visit the ecliptic line and also some of our planets. NASA defines the ecliptic plane or the ecliptic line as an imaginary plane or line containing the Earth's apparent orbit around the sun. Now, in the course of a year, the sun's apparent path through the sky also lies in this plane or in this line. And consequently, so do our planets and also the sign of the zodiacs, the zodiac constellations. The zodiac constellations that are currently in the southern sky right now and visible along the ecliptic, they start in the east and they travel actually all the way to the west. So our ecliptic line again starts in the east, and again it's our apparent path around the sun and the sun's orbits, or it's the sun's plane throughout a calendar year. So it starts in the east and it goes to the west. And along the ecliptic line right now, the constellations, the zodiac signs that are visible are Aries, Pisces, Aquarius, Capricornus, and Sagittarius. Now, if we were to take away the landscape, we would also see Scorpius here. And Scorpius, since it's about 9:30 tonight, it's actually already set behind the landscape. Now, not only do the zodiac constellations travel along this ecliptic line, but so do our planets. During the summer months, in Sequoia and Kings Canyon National Parks, from mid-June to mid-September, we get a great understanding of the ecliptic line because we have a lot of famous zodiac constellations and also a lot of planets that are traveling along this line. But another great thing about the southern sky here in the summer in Sequoia and Kings Canyon is that when we look to the southern sky, we're actually looking at our galaxy's galactic center, so the Milky Way's galactic center. And at our galactic center lies a supermassive black hole right at the center. Now, another great thing about the summer skies in Sequoia and Kings Canyon is that the Milky Way is totally visible on a dark night. And the Milky Way helps us to join our northern sky and our southern skies. We see here in the south, the Milky Way, here's the Milky Way travels here from the south, and it spans across the entire night sky. And we can see it in an arc traveling from our kind of southern sky all the way here to the north. Along the ecliptic line, there are also our planets, like I mentioned earlier. Tonight, we're going to focus on Jupiter and Saturn. And first, we're going to travel to the planet of Jupiter. Now, Jupiter is the fifth planet from the sun and is by far the largest planet in our solar system. It lies 426 million miles away from Earth. And one of the defining features of Jupiter, we can see that here, is the giant red spot. I'm going to focus us a little bit because it's moving through our screen. So is our giant red spot right here, and also the 4 Galilean moons. We see our Ganymede, Io, Europa, and Callisto. Callisto's behind Jupiter right now, so we can't see it right now, but those 4 Galilean moons are what make Jupiter so distinct. Now, this is what Jupiter looks like through Stellarium. Again, you see lots of colors, lots of detail, but through a telescope, we're still actually able to see some of that deep detail. Through a telescope, we're able to see those red lines, and when we time it right, we can see the red spot, and we can also see the 4 Galilean moons. And we're going to show you a picture of what Jupiter would look like through the telescope if you were standing here with us today. All right, next after Jupiter, we're going to travel to the planet of Saturn. Saturn is really close to Jupiter right now, so we're not traveling too far. And we are going to visit Saturn fairly, and it is one of the most popular planets of our solar system because of its distinguishing rings. It's the 6th planet from the sun and the 2nd largest in our solar system. Saturn's most defining feature is its rings. And what I think is the most fascinating thing about Saturn is that while all planets reflect the lights of the sun, Saturn's rings have enough material within them that not only does the planet's surface reflect the light of the sun, but the rings also reflect the light of the sun. And we can see that when we look through a telescope. So we're going to show you an image of Saturn through the telescope and see if you can see the rings. The first time I saw Saturn through a telescope was when I was in 6th grade. And I was so amazed by those rings and by what I saw that night that I started building my celestial map. And I've been working on that map ever since. And I encourage you tonight, if there's anything that you see that we're going to show you that really just captivates you, start your map there and start your map tonight with us. As we travel to the last point on our map, the east, we will visit our last constellation, which is the constellation of Andromeda right here. And we'll put on the constellation art so we can find her. So we have the constellation of Andromeda. Andromeda is the daughter of Cepheus, which is located here, and of Cassiopeia, and she is the wife of Perseus. They all closely lie together in the night sky during this time of year. And the story of Andromeda is actually pretty sad. But to sum it up, basically, her parents were pretty awful people. And they actually so Cepheus and Cassiopeia tied poor Andromeda to a rock as a sacrifice to the Hydra, which is a big, scary water snake, to appease Poseidon, because Cassiopeia could not stop talking about how beautiful she was. Now, don't worry, the Hydra did not get her. Andromeda was actually saved by Perseus, and after Perseus saves her, he kills the Hydra, and they go on to fall in love and are actually the ancestors of Hercules, who we visited earlier tonight. Now, what I love about the Andromeda constellation is that it actually is also home to the Andromeda Galaxy. The Andromeda Galaxy, or M31, is our closest galactic neighbor. And it lies about 2.5 million light years from Earth. This galaxy is so bright, it's at about a 3.1 magnitude, that is actually visible naked eye from Earth. So you don't even need binoculars or a telescope to see this constellation. So we're going to zoom in here. You can see Andromeda. You can actually see it's surrounded by a couple different Messier objects, but Andromeda Galaxy here. We're actually going to show you what Andromeda would look like through a telescope. Now, when we took the photo of Andromeda, it was at the very beginning of the wildfires that we are experiencing here in California. So it's actually going to look quite orange when you see it. And that's not because we alter the color or because Andromeda is orange, but that's actually the effects of the smoke in the air. So we're going to go ahead and show you what Andromeda would look like through a telescope. So Andromeda, again, it's amazing through a telescope, but what I love about this galaxy is you can see it naked eye from Earth. Now, in about 4.5 billion years, the Milky Way galaxy, which is our home galaxy, and Andromeda are expected to collide. Now, scientists think that Andromeda is traveling at us at about 68 miles per hour, traveling at us about 68 miles per second. So every second, Andromeda gets 68 miles closer. Now, we don't know what our solar system's fate is when our two galaxies collide, but what we do know is that the Milky Way galaxy and Andromeda will form a new galaxy rumored to be called Milkdromeda. As we travel away from Andromeda tonight, we only visited a few places of the night sky here in Sequoia and Kings Canyon National Parks. But again, we encourage you to continue going outside at night and building your celestial maps. Continue to find the stories in the stars and draw them on your maps. Ask questions on your maps and learn about the mysteries that are waiting for you to discover. And most importantly, continue to protect and preserve our night skies. Here in Sequoia and Kings Canyon National Parks, we at SPC, alongside the National Park Service, help to preserve and protect not only the giant sequoias, the largest trees in the world by volume, and Kings Canyon, one of the deepest canyons in the world, and we help preserve and protect all the animals and all the plants that call this place home. But we also preserve and protect your opportunity to see the stars and to see the night sky. Night skies are disappearing all around the world because of light pollution, and we're losing important pieces of our celestial maps. Our collective celestial maps are what help us to unlock the mysteries of the universe. And so we all need to be able to see the stars to continue that great work. To learn how you can help preserve the night sky, please visit the International Dark Sky Association website at www.darksky.org, or visit our website and look at our Dark Sky Festival presentation, where you can learn about light pollution and how you can get involved to save the dark. Before we say goodbye tonight and wrap up our star party, we want to invite you to share your celestial maps with us on our SPC Dark Sky Facebook page. The link is down below in the description. And we want to see how you see the night. Because again, the best celestial maps are the ones that we build together. So again, share those maps with us on our Facebook page. And thank you all for joining us for our first ever virtual star party. And please visit our website at www.sequoiaparksconservancy.org/Dark Sky Festival for more information and also a description of festival events.